definition of this function. Now notice the argument here is a const reference. So here the name of this local variable is numbers. Its type is a std : vector of int, and it's a const reference. So this was important. The const qualifier here says that this local variable numbers is constant. That is, it is only used to read and it cannot be overwritten. So we can only read the elements of this vector, we cannot change it. The second here, the important thing here is that it's a reference. That is, we are not passing this vector by value, we are passing it by a reference. So by passing it as a reference, we are not allocating any new memory when we do this function call, and we will also not copy the vector, copy from one vector to another vector. So suppose this was not a function call by reference, it was a function call by value. Now a local variable numbers needs to be allocated when the function call happens. The size of the local variable will be equal to the size of the passed vector, and each element of the passed vector will now be copied to this local variable numbers at the time the function call happens. All this happens implicitly in C++, but this additional overhead will cause your function to run slower. So whenever you are passing an inbuilt template like vector, map, list, or any other resizable container in C++, make sure you pass it with a reference so that you will not have this additional overhead of allocation, copy, and deallocation. And in order to make sure that this variable numbers is not accidentally modified within the function call, declare it as a constant using the const qualifier. Now within this function, I'm declaring a local variable called sum and iterating through the elements of this vector numbers and adding each element to this local variable sum. So this is computing a running sum and returning the sum at the end of the function call. Now let's execute the program and see what happens. So I want to put some breakpoints in this function introduce underscore vectors to show you how the pushback works. So let's put some breakpoints. Okay, so now let's continue and go to the watch window, and this time let's put numbers in the watch window. Now notice the size of the numbers is equal to 5, and the 5 initial values are equal to 1, 4, 16, 24, and 91. Now the first time I call push underscore back, the size is equal to 6, so the new element is added at the end of the vector, and the fifth element now is equal to 23. Now again, when I call push underscore back, size should be equal to 7, and the last element should be equal to 32. Okay, so now stdcout numbers dot size should be equal to 7. So we should see 7 on the console, and then we are printing the values within this array, first using the square brackets operator and second using the special format. So let's continue and print each element of the array. Okay, so each element of the array will displayed using the two different ways. Now let's see what will happen when I call this function using constant reference. So first I want to show you what is the address of this variable numbers. Okay, so the address is 91F32EFT8. Now let's see whether the address of this local variable is also the same. Okay, now notice the local variable numbers is again 91F32EFT8. So since we passed it with reference, it refers to the same memory location, and after this function call we will be printing the value, which is the sum, which should be equal to 191. So now let's stop the program, and instead of passing this vector by reference, let's pass it by value. Let's see what will be the address of this local variable numbers. So just to let's just give it a different variable so that we will have both numbers and numbers1 that we can see the address of. Okay, now let's continue. Oh shoot, I need to add a breakpoint within the function called sum, so let's restart. This time let's go into the function call. So before that I want to see what is the address of this variable numbers. So this time it is 46092 ff3 f8. So now let's go into this function sum, add a breakpoint, and check what is the address of this variable numbers1. Now notice numbers1 has a different memory address. So it is 4609 to FF648, which is different from FF358. So by passing it by value, C++ created new memory, copied all the elements of the first vector into the second vector, and at the end of this function call, this memory will be deallocated. So in order to avoid this expensive allocation copy deallocation cycle, you should declare the function, you should pass the vector using a constant reference instead of passing it by value. So this was an example of showing what happens when you pass arguments to a function using value and reference. Now let's look at a different example of passing elements to a function by value and reference through this example of swapping two numbers. So here in the main, I've written two numbers a and b. A is initialized to 5, b is initialized to 10. First we will print out what is the initial value of a and b. Then here within the main, I'm swapping them using a temporary variable. So here I'm creating a temporary variable called temp initialized to a and overwriting a with equal to b, and then swapping the value in b using temp. So this should swap a and b, and after that we will print again the values of a and b. Finally, we will use function swap to swap the values of a and b by passing a and b as arguments. Now within this function call, I'm calling this function by pass by value. So a1 and b1 are new variables that are local to this function, which has a copy of a and b. And we use the same 3 lines that we wrote in the main function. This time it is encapsulated within this function swap that swaps these two variables a1 and b1. So let's see what will be the output after these 3 function calls. Okay, so let's first remove all these breakpoints. And first let's check what is the value of a and b before the swap. So a is equal to 5, b is equal to 10. Now after swapping it in the main, a will be equal to 10 and b will be equal to 5. So the swap happened properly. Now let's check what will be the value of a and b before calling this function called swap. So before calling the function swap, a is equal to 10, b is equal to 5. And now let's see what happens after calling the function swap. Now notice after the function call, the values of a and b are the same, which is a is equal to 10 and b is equal to 5. Now the reason why this happened was because we called this function by passing the arguments using values instead of references. So locally we swapped a1 and b1, but this did not change anything to the variables a and b that were defined in the main function. If we want the result of this swap function to affect the main function, affect the variables in the main, we need to pass the arguments with as a reference. So here when I call the function swap with two references, A and B will point to the same memory locations of A and B, variables A and B in the main program. And this swap here will swap the contents of the variables A and B that were in the main. Now let's compile the program. Now notice this will not compile. So here, even though I have two functions swap, both of them have different signatures. One has integer reference, the other one is integer passed by value. This does not compile. So it's not sufficient to only have the difference between two functions, overloaded functions as passed by value and passed by reference. You need to additionally have different data types, as we saw before. Let's comment this version of the swap. Now the program compiles, and this time let's check what will be the swapped values after the function call. So again, before the function call, the swap A is equal to 10, B is equal to 5. Now let's see what is the value after the function call. So notice now, after the function call, A is equal to 5 and B is equal to 10. So if you want to have the effect of logic that is local to a function to be visible outside the function, you need to pass the parameters in the function using references instead of value. So previously, when we called swap with pass by value, the swap happened local to the function call. However, the variables in the main were still remained unchanged since they were passed by value and not reference. Now finally, I want to show you how to write a function by returning multiple values from a function. So here I'm creating a function called return underscore multiple underscore vals. So this function will show you how to return multiple values from a function. So far we have seen how to return a single value, which is by default what's the case with C++. Now if you want to return multiple values from a function, you can use the special type called tuple in C++, wherein you declare std : tuple with different data type of parameters. So here I want to store within this tuple a string, integer and a string. And to create a tuple, you can use this special method called std : make underscore tuple. So the default parameters that you pass to this, make underscore tuple are the parameters that are used to initialize these three variables stored in std : tuple. So the first parameter is initialized with value equal to Windows space. The second parameter is initialized with value equal to 10. The third parameter is initialized with value equal to is not awesome. So in combined, it says that Windows 10 is not awesome. Now, to receive these three different values, you can use the special type called std : type. So here in the main, we are declaring three variables. The first one is string 1. Second one is num, which is of type integer. Third one is string 2, which is again of type string. And we will use std : type string 1, num, and string 2 to receive the three different values written from this function, return underscore multiple values. And line 167 prints the string num and string 2 using cout. So let's run the program and see what will be the print. If everything is successful, we should see Windows 10 is not awesome, which is what is displayed. So in order to return multiple values from a C++ function, you can use std : tuple. To create a tuple, you can use std : make underscore tuple. And to save the returned values, you can use std : type. Now all these are defined within the special file called tuple. So to use these, you need to include tuple at the beginning of your program. Also to use vectors, you need to use #include vector at the beginning of the program to use vectors in C++. So this concludes the topic on pointers and references. Next time we will begin by looking at examples of classes in C++. Thank you.